So I'm going to be giving you the arguments against incineration. And I will say a little bit about the alternative in general terms, but I would like, once you've beaten this incinerator, and I'm sure you will, once you've beaten it and you're looking for a rational alternative solution, I'd like to come back and give you a presentation on the zero waste strategy, which I have been involved with literally worldwide, 69 different countries. So, first I'll start off with, I'll introduce myself formally, then we'll give you a list of the arguments against incineration and then a better strategy for New Zealand. So I'm a retired professor of chemistry. I specialized in environmental chemistry and toxicology. And I have been researching waste management issues since 1985. That was the year that I got involved with the local incineration battle. And the issue has now taken me to 69 different countries. Between 1985 and 1995, Work on Waste USA, which is the group I helped to found and directed for many years, we helped communities in North America stop the building of over 300 waste to energy trash incinerators. I hate that name. You'll see why later on. Now, I hasten to add, helped communities. I have never defeated an incinerator, me personally. I have inspired communities to work together and beat incinerators. And we've helped that process with networking, with presentations, with a newsletter, Waste Not, which my wife put out, with videotapes, etc. But to beat an incinerator, the community has to get organized and work together. Now, only one incinerator has been built in the United States since 1997. Essentially, this industry has been dying since the 1990s. I mean, they still have incinerators operating, but it is the most unpopular technology in the United States after nuclear power. Nobody wants to live near an incinerator. I first came to New Zealand in 1997 at the invitation of a community in the North Island near Merry. They wanted me to help fight the olivine incinerator, which was proposed for Merry and supported by the local Maoris, incidentally. But when they found out about the dangers it posed, and they saw through the sales hype that they'd been given, they came out against the incinerator. Meanwhile, local farmers were appalled when they heard about the impact of incinerator emissions on farming, particularly grazing animals, and I'll have a lot to say about that later. So I'll list the arguments against incineration first, and then come back and go through each one in more detail. So here they are. It's a lazy solution to waste management. It's a Rambo approach. You know, you don't like something, get out a flamethrower and zap it. Very American. It's an unsustainable solution for resource management. And I'll be explaining that difference between waste management and resource management really came into focus when we entered the 21st century. It's extremely expensive. Very few jobs and small business opportunities are created for this enormous capital expense. And it's a waste of energy, not waste to energy, waste of energy. It doesn't get rid of landfills, but replaces them with toxic ash landfills. The landfill that you need for an incinerator is more toxic than the rubbish landfills that you're replacing. Less waste is diverted from landfills, 75%, that can be achieved by incinerators. Less waste is diverted from landfills using incinerators, that's 75%. We now have communities over 75% diversion without using incineration. Doesn't make sense. Incineration puts highly toxic substances into the air, which threaten public health and shorten lives. Incineration is poorly monitored. From a scientific point of view, it's outrageous. And there are far better alternatives, a better strategy, which is already happening in certain places in New Zealand and in many other places around the world. Now, there's some more arguments which are specific to this project. Number one, the company, I believe it's called Global Metal Solutions, has never built or operated a trash incinerator before. Incineration is incredibly complicated, certainly from a chemical and a toxicological point of view. It's incredibly complicated. And to leave this to a newcomer is preposterous, really preposterous. And particularly in an agricultural area, which is particularly vulnerable to the air emissions from incinerators. Incredibly, there has been no environmental impact statement or health risk assessment prepared for this project. And what I've read about this project is more like a sales hype from the manufacturer. It's saying how good it is, telling you all about the benefits, but very little bit about the risks. There are huge areas of concern which have been completely omitted in what I've read so far from the company. Nor is New Zealand experienced in monitoring trash incinerators. There's no trash incinerator operating in New Zealand at the moment. And so you have few laws to protect the public from such facilities. And not only that, you need, I'm going to say this again, but I'll say it because it's important. You need three things to protect the public from incineration. You need strong regulations, yes, but you also need scientific monitoring to make sure that the facility is meeting those regulations. And thirdly, you need aggressive enforcement so that if the incinerator does not behave properly, doesn't do what it promises to do, you've got somebody to shut it down. Now, there are many countries where that doesn't happen. What happens is so much political capital is put into building these things that the governments don't have what it takes to leave the community with a white elephant. So New Zealand does not have experience with regulating trash incinerators, monitoring trash incinerators, nor do we have much of an idea of how good they're going to be at enforcing whatever regulations they put in place. Now, there are other issues. This facility is located very close to a community, and noise is an issue. Not the noise of trucks going in. They say they're not going to be operating at night. No. What you have inside a facility are front loaders. Front loaders are picking up the trash and dumping it into the pit where it's then fed into the furnace. Those front loaders, when they reverse, have a wah, 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 as they reverse. And that noise will be heard very close to the community where people are living. That's all the way through the night. Now, another issue, because they hardly discuss ash in the project here, they didn't discuss ash very clearly, but it's very toxic, and the fly ash is very light, and so you have the workers in the facility are going to be exposed to this fine ash when it's being transferred, when it's being loaded into trucks. And when those trucks leave the facility, they might have ash on their wheels, water containing the toxics from the ash, because the bottom ash is quenched in a water tank before it's sent off a site. And that liquid drips from the back of trucks. And when that water evaporates, the toxics will be in the environment. And some of the ash will blow off the trucks. They're not always very secure. So one way or another, you're going to get accumulation of very toxic, fine ash material on the roadways in which these trucks are coming in and out. And the other issue I would touch upon is property values. Because this is so close to where people are living, there's no question that property values will diminish. And I would suggest to you, if you look at the overall loss of property value for all the houses in the area which will be impacted. It's going to make mincemeat of whatever benefits this incinerator will have on the local economy in terms of jobs, etc. And as far as that is concerned, the jobs are not clean jobs. Some of those jobs are very dirty, handling the ash and so on, are not a nice job for many. Many of their top people will probably come in from Germany if they go through with a German facility. So there was a study done in the northeast of the United States many years ago. And what this study found is the property values of identical properties went up for every 1/10 of a mile from the facility. The property values went up by a certain amount. But here's a little experiment or a test that you could try yourself. Take a picture of your property from some distance away, if you can, the end of the street or from a hill. Try to get your property with other properties around it and a skyline. And you have that photograph. And on that photograph, I'm sure one of your children will be able to put in the stack of an incinerator. The 60-foot, 100-foot, or even higher chimney stack. And you take that to any real estate agent and show them the first picture and say, well, what's the rough property value of this property? You can give them the data, know how many rooms, etc. And then show them a second picture with the stack in view, and then ask them, would that have the same property value which you told me for that house? I'm pretty certain that you're going to find that a real estate agent seeing that stack will say, well, what is that stack? When you tell us, oh, it's from an incinerator. Oh, what's that? Then you tell them, will then pretty quickly tell you, no, that second house with the stack visible somewhere in the vicinity will have less value. But don't take my word for it. You ask your real estate agent. Okay, now I'm going to go through those 10 arguments in a little bit more detail. Now I'm just going to move this. Okay. So in my view, incineration is a lazy solution. It requires no change in community and individual behavior. Basically, instead of sending trash trucks to a landfill, which is a hole in the ground, you send them to a hole in the machine. So you're not changing your waste haulers, you're not changing the citizens in terms of what is collected. Whatever you send to landfill is going to go to the incinerator. And most importantly, you're not changing industrial producers of packaging and products, which have to change because we can't deal with all this single-use plastic. But it doesn't matter, with an incinerator in town, all of this stuff is going to go to the incinerator. Incineration essentially is business as usual when the world is demanding change, particularly since we've entered the 21st century. And again, I'll come back to that point a little later. Now, incineration is an unsustainable solution. Let me explain. Different times demand different questions. In the 20th century, when I began, we were talking about waste management. And the issue was, how do we get rid of our waste efficiently with minimum damage to our health and the environment? And the argument was between landfills and incinerators. If you didn't like the incinerators, then you were told how bad landfills were. And so this argument went on essentially for 100 years. Either you burn it or you bury it. And there were supporters for each strategy. But in the 21st century, I put to you, it's no longer about waste management, it's about resource management. And the question becomes, how do we handle our discarded resources in ways which do not deprive future generations of some, if not all, their value? And so, in other words, in the 20th century, the key issue was safety, and there are still some safety issues left in the 21st century. But the main issue in the 21st century is sustainability. And incineration is the absolute opposite of sustainability. It's business as usual. It's the ultimate step in the throwaway society. Now, a word about sustainability. We would need 5 planets if everyone consumed as much as the average American. I think we need 2 planets if everyone consumed like the average European. But meanwhile, India and China are copying our consumption patterns. And every time we try to point a finger at pollution in China or the explosion of consumption in India, we're always told, well, look at the United States, look at what you're doing. And we have no argument, really, unless we set a better example, and we're trying to do that. But something has got to change from what I call overconsumption. It's overconsumption which is giving us a huge global problem. And the best place to start that fight is with waste, because apart from the very poor, everyone on the planet makes waste. And all the time we're making waste, which is essentially mixing everything together with these 10 things, we are part of the problem of an unsustainability. But when we get good political leadership, we're asked to source separate, then we're part of the solution, part of moving towards sustainability. And of course, we're not going to get there overnight, but it's a wonderful tool. Governments need to realize that when they talk about global problems, waste is what puts the whole planet in everybody's hands. The responsibility, we all have responsibility. Meanwhile, this is what we're doing to the planet. We're consuming it like a hamburger. We were consuming the planet as if there was another one to go to. That's taken from the cover of this book by George Ritzer called The McDonaldization of Society. So overall, we have to convert a linear economy to a circular economy. The linear economy, 4 steps: the extraction of raw material, transport those materials around the world, put them into factories, manufacture products, televisions, cars, you name it, and then consumption of those products, and over a relatively short time, throw away those projects, and we have waste. And that linear economy is producing all the global problems that you think of. First of all, we use an enormous amount of energy, fossil fuels, extracting raw materials, an enormous amount of energy transporting these materials around the world, and then more energy manufacturing new products, and more energy transporting these products to the market, and then more energy transporting the products to the landfill, and so on. Now, all this energy use, of course, produces carbon dioxide, and it's that carbon dioxide which is giving us climate change. Again, simplifying it, it's overconsumption that is giving us climate change. How do different waste handling methods impact the linear economy? Well, let's look at them. Let's look about looking at landfills. When we bury our waste, we have to go back to square one. Those resources you bury, you're not recovering those. So by going back to extraction, you go back to step one in the circular economy. There is no movement towards sustainability. There's no movement away from the linear economy. If you burn or destroy the waste in a gasification or any other way you destroy waste, the same thing applies. Every product and package, you've got to go back to square one and start again. So there is no movement towards the circular economy. Incineration perpetuates the linear economy. Now, on the other hand, when you recycle your discarded objects and materials, then you don't have to go back to extraction. You can short circuit, you can go back to manufacture. You can send those materials straight to the manufacturer, and it's cheaper for them to make new products. But more important, it saved the planet a lot of global impacts, including energy use. If you reuse the whole product, if you reuse the book, the compact disc, the clothing, the car, the the record machine, the video camera, whatever, then you don't have to remanufacture that. You can go straight back to the consumer in charity shops and reuse operations and places like Raglan. They're doing a wonderful job with reuse, making a lot of money and creating jobs. In fact, if you did it all over New Zealand, you create far, far more jobs than you would with incinerators. And of course, far less global impact, far less global warming. And similar arguments apply to compost. When you take the discarded food, vegetables and so on, and compost them, you avoid the use of topsoil in some cases and diminish the use of fertilizers, which are high energy industries. So you cut back on global warming, energy use, and so on. And more importantly, every bit of food scraps that you convert to compost, instead of producing methane in landfills or carbon dioxide in incinerators, you're taking carbon dioxide out of the air. You're growing more vegetables, more fruit, more wine, more trees, more forests. Yes, this is the big fight against climate change, is composting. Very big component. All of it, recycling, reuse, and composting, all fight climate change. So this is an artist's rendition of what it means. You go for the linear economy on the left to the circular economy on the right. What do you got to do? You've got to cut back on the raw material use as much as you can. We live on a finite planet. Those raw materials are finite, except for wood, etc. And we have to reduce dramatically the waste, so that you take those two out and you've got the circular economy. Easier to do in a picture form than to do in reality, but we have to start. Now, what I've learned after, 38 years of this working with waste, is that you won't solve it with technology. It's not a high-tech problem. It's essentially a low-tech problem. There are no machines that can get rid of waste, nor, if you had them, would you want to do that, because what you've got to do is to recover the resources. So the waste problem is going to be solved with better organization, better education, and better industrial design. And when we eventually get round to talking about the zero waste strategy, you will see how those principles or practices are applied. Now, basically what you're doing in the 21st century is, if you build an incinerator, you are advertising to the world that your community, your country, was not clever enough politically or technically to recover your discarded resources. You're trapped in the throwaway society. You're trapped in the 20th century. You have no imagination. You have no vision, essentially, or rather your leaders have no vision or imagination. To make matters worse, incineration is extremely expensive. It is the most expensive way of handling waste, and it's the most expensive way of making electricity. Why is that? Well, half the capital costs, I should say, as a power station, waste is the dirtiest fuel that's burnt in any power station. You've got dirty coal, clean coal, you've got oil, you've got natural gas, but more dirty a fuel is waste. And the end result is that half your capital costs for building an incinerator, millions of dollars, goes into the air pollution control device. If you look at this picture, on the right-hand side, under the word electricity, is all the highfalutin apparatus that you need to capture the particles, the gases, the toxic emissions, in other words. And that's half your cost. Half your capital cost goes into that. Now, a 500-ton-a-day incinerator, roughly, that meets European standards would cost about $200 million US. Very expensive. And what should concern the community and decision makers in New Zealand is it takes about 30 years to pay back those loans, which means you don't have much flexibility. If you build the darn thing, you've got to use it. You've got to use it to get the tipping fee and to get the sale of electricity. You've got to keep using it, which means you're not going to find it easier to do recycling and reuse. Whatever incentives come along later, whatever new technologies and communities in New Zealand get better and better doing it, you won't be able to copy them because you're lumbered with this destruction machinery. So how do you pay off these massive loans? Either the company or the community or the country. Somebody's got to pay it off, right? Well, most of the income of incinerators comes from the tipping fee. That's the amount of money that whoever delivers waste to the facility, a waste hauler, a private company, a community, a region, whoever, a local government, that's how much you pay per ton for delivery. And that can be very high. And without government subsidies, less than 25 subsidizing the energy production. In Italy, for a few years, they required utilities to buy the electricity from trash incinerators at 3 times what they would have paid from a fossil fuel power station, which was ridiculous when you remember Italy is a very sunny climate, and they should have put those incentives into solar panels throughout Italy. That would have saved far more energy than was created by their trash incinerators. Another problem with this tipping fee, as the tipping fee goes up, your facility, as far as the waste industry is concerned, is not very competitive. In other words, the waste haulers will see that it's cheaper to take their waste to landfills even further away than to take it to the incinerator. And in some places in the United States, the result is that some states have tried to impose a requirement that the waste haulers in the area take their waste to the incinerator and pay the tipping fee much higher. For example, in Pennsylvania at one time, it was $45 a ton to send waste to landfills in Pennsylvania. And it was $90 a ton to send waste to trash incinerators in New Jersey. And the waste haulers resented this, and they took out a lawsuit. It went all the way to the Supreme Court, and the Supreme Court ruled in favor of the waste haulers. In other words, you could not force the waste haulers to take their waste to the incinerator, with which then the communities that had built incinerators in New Jersey were left adrift. They could pay for their operating costs, but they couldn't pay back their capital costs, and they begged the state to bail them out. Another thing to bear in mind, this is a private company, a recycling company that deals with cars, that wants to build this facility, and they have their reasons. They want to get rid of the fluff, which can be very toxic from car demolition and shredding. And they want to get rid of waste tires, which also produce very toxic things when they get rid of them, burn them. Now, it's interesting to note, and you'll find this in the documents supporting this or part of this application. I think it's from the Burl Consulting Company. They explain that the 2 major waste hauling companies in New Zealand have shown no interest in building or owning so-called waste-to-energy incinerators. So it doesn't look to me as these waste haulers, the big companies, Waste Management, etc., who handle waste in New Zealand, are going to be eager to bring the waste to this facility and pay a very high tipping fee to a competitor. Now, Harrisburg, Pennsylvania went bankrupt trying to pay off its incinerator loans. You can check that out in the literature. It's a well-known story. Now, for this huge capital expense, very few jobs and small business opportunities are created for the enormous capital expense. I know they paid a huge amount of money, I think about $400 million to build an incinerator in Brescia, Italy, and they only created 80 jobs. $400 million to create 80 jobs. This is absolutely absurd misuse of taxpayers' money. And it will be that ultimately it will be the taxpayers who bear the burden of paying these loans back. So what are you doing? Incineration is putting money into machines, not people, and putting money into corporations, not communities. And by the way, if this company tries to tell you that there's competition for this facility throughout New Zealand, you say, where is the competition? Show me the communities in New Zealand that are lining up to embrace this project if we say no to it. There won't be a long list. What you will find as time goes on is that more and more communities that are approached in New Zealand reject these facilities. And I must say, far more jobs and business opportunities are created with a combination of reuse, recycling, and composting, and all the other steps involved in a zero waste strategy. Now, number 5, despite the name, incineration is a waste of energy. It's good public relations, people, and people often think that this happened in Bangladesh, in Khulna. I got a request, come and help us in Khulna. What they're planning to put waste on ships from New York City and send it over to Khulna, Bangladesh. And they said to the people in Khulna, Bangladesh, we want to build a power station for you and generate electricity. And all we need from you is your waste. And those people came away thinking, oh, these people are very clever, these technologists from Germany or Sweden, and they have this way of taking waste and converting it into energy. No, and make a profit doing it. No. The profit comes from people paying an exorbitant fee, the tipping fee, to use the facility. Very little money comes back from the sale of electricity. And they are a waste of energy. Why? Well, locally, you can see some energy produced. Yes, locally, you'll see the wires, and you're producing electricity. It goes into the grid, and yes, people can power a few light bulbs. But globally, it's a huge waste of energy. Why? Because you've wasted the opportunity to recover the embedded energy. The embedded energy is the energy that manufacturers have put into the products all the way along the line. The energy you put into extraction, the energy you put into transport, the energy you put into manufacture. This is the embedded energy. Here we go again. Energy in extraction, energy in transport, energy in manufacture, energy in transport, etc. None of that embedded energy is recovered when you burn waste. All you recover when you burn waste is the calorific fuel of the combustible fraction, the paper, the plastics, the tires, etc. But that's actually only about 25% of that calorific value is actually captured. But that, in turn, is a very small fraction of the energy the global economy has put into the products that you're destroying. And what we are supposed to be doing is not destroy them, but to recover them as much as we can with source separation, door-to-door collection, recycling, composting, reuse, repair, and waste reduction initiatives. And so I'm jumping ahead of myself. But to give you some idea of how much energy is being wasted when we burn things, the green column here is the energy, the yellow column is the energy you get from incineration when you burn these different materials, the yellow column. The green column is how much energy you save when you recycle those same materials. So the one I've highlighted here is PET plastic. That's the plastic of milk bottles, plastic milk bottles. You can see 26 times more energy is saved our planet recycling those PET bottles, then allowing them to be burnt in an incinerator. Incinerating plastics is an environmental crime, in my view. And if you look at it, this consulting company in 1994, they did the calculation. I showed you the savings for specific material, but if you look over the whole waste stream, recycling a ton of waste saves over 16 million BTUs. Burning 1 ton of municipal solid waste generates less than 5 million BTUs. And incineration is a waste of energy, a waste of opportunity for recovering and saving energy in the next cycle when you recycle, reuse, and so on. Now, as far as the energy output compared to the environmental impact, compare the power generated by incineration with wind turbines. You need, rule of thumb, about 50 tons of waste per burn to get a 1 megawatt rating. So 150 ton, a modern wind turbine has a rating of about 3 megawatts. So if you burn 150, or if you burn 150 tons, you're getting the megawatt rating of 1 wind turbine. And you're going to be burning 450 tons here, I think, about. So you're talking about 3 windmills. And I know there's opposition to wind farms, but surely I think most people would rather live with the impacts of wind farms than breathing the air near incinerators. Now, incineration produces a toxic ash that nobody wants, and there's very, very little discussion of this ash in the promotion material from the company. For every 4 tons of trash burned, about 1 ton of ash or more is created, depending upon the incinerator. The ash is produced in 2 places: under the grate, that's what we call bottom ash, and in the boilers and the air pollution control devices. This is after the gases have left the furnace. In other words, incineration does not get rid of landfills. You still need a landfill for the ash that you've produced. Now, the bottom ash is about 90% of the ash. That falls through the grates of the furnace. You see that on the left-hand side. On the right-hand side, the fly ash is coming from the boiler. You see that in the middle, and the air pollution control devices. And that's about 10% of your total ash. Now, the bottom ash is toxic, no question. And the fly ash is very toxic, no question about that. Just an example, these are the absolute levels of toxic metals in the fly ash from 8 incinerators in New York State. This will go back a few years. But as incinerator gets better, the fly ash gets more toxic. So I don't think you have reason to believe that things have changed for the better. But you can see, as far as lead is concerned, fly ash is extremely toxic, ranging from 3,000 to 17,000 parts per million. And cadmium, too, extremely toxic. I throw this in to underline a point. Elements, and all metals are elements, cannot be destroyed. And when you build an incinerator, all those toxic metals that you've used in products, from cars to incinerators to laptops to cell phone, those metals cannot be destroyed in incinerators. They're elements. You cannot destroy them. Now, the worst that can happen is those metals go out into the environment. More about that in a moment. The best you can hope for is it goes to the fly ash. And then the fly ash is very toxic, and you've got to handle all those toxic metals that you've collected and try to keep them away from the food chain, and keep them away from the environment and so on. And so you've got these ash landfills, which are going to be there forever. Now, common sense says the better the incinerator gets at protecting the air from toxic metals and dioxin, the more toxic the fly ash. And many countries treat their fly ash as hazardous waste without even testing it. They don't bother to test it. They know it's hazardous and they know they have to treat it as hazardous waste. So in Germany and Switzerland, the fly ash is put into nylon bags and placed in salt mines. In Japan, many of their incinerators vitrify their fly ash, and some even vitrify their bottom ash because they just don't want those metals leaching out of the ash. You know, I once had a debate with the combustion engineers in Japan. One of the things two things they said to me which shocked me. Number one, when I pointed out there were very few jobs created from incineration, the capital costs, they said, we're not worried about the social ramifications of incineration. Our job's to get rid of waste. Okay. Then I said, well, they're extremely expensive. And I talked about this, having to vitrify the bottom ashes. We're not worried about the expense. It doesn't matter how expensive, we will do it. That's your attitude. But I don't know whether New Zealand has the same attitude to how much it's going to cost and how many few jobs it creates. Now, in Denmark, which is perceived as a wonderful green country, they have a wonderful solution for the ash. They send it all to Norway. All the bottom ash and the fly ash generated in Denmark goes to Norway. Hardly a sustainable solution. In the UK, they send their fly ash to hazardous waste landfills. And you might think that means that all that fly ash is carefully sequestered. No. This is a ash landfill near in Gloucester. And I've talked to people in those houses. They're very, very upset with this ash, which gets onto their washing, on their gardens, and so on. Absolutely irresponsible, in my view. In the US, the bottom ash and the fly ash are mixed before testing, and it's the combined ash, which is, and I'm talking about a leachate test, not the absolute levels, but what they think is going to leach out in a landfill. And because now that they are passing those leachate tests in bogus reasons, in my view, but that's another story. But the result is a combined ash in the United States goes either regular landfills or monofills. In fact, you're not getting rid of landfills. Less waste is diverted from landfills, 75%, than in many communities with a zero waste program. I'll give you an illustration of that in a moment. Here's a combined ash landfill for Haverhill. They incinerated in Haverhill, Massachusetts. One incinerator, huge. So this is where a bit of Monty Python comes. Think of incineration as 3 boxes. Okay, John. Well, in the first box, that's a furnace. Hundreds of tons of waste are converted into trillions of tiny particles of gases. Oh, really, John? Well, then in the second box, we go to great lengths and great expense to capture all these particles and gases. Okay. Oh, and what do you do when you captured all those tiny particles and gases, John? Oh, we put them in a third box. We put them into a large hole in the ground. Oh, really? But I have a question, John. If you didn't build box 1, you wouldn't need box 2 or box 3. Remember, half the money for an incinerator goes into box 2. So aren't you creating a problem which, if you thought about it, is avoidable? If you could avoid box 1, you wouldn't need box 2, and you wouldn't need box 3. Common sense from Monty Python. By the way, I played soccer with John Cleese when I was at college in Cambridge. Okay, I've said that. Now, here's some interesting number for you. By 2011, San Francisco had overtaken Brescia in Italy. This was that huge incinerator, $400 million incinerator, in diversion from landfill without incurring the expense of incineration. So here are the numbers. They carefully recorded the diversion from landfill, which when they started in 2000, 50% And they eked their way up. By 2011, they'd reached 77%. But look at it. Brescia, with this massive incinerator, by the way, don't underestimate the size of this thing. When you look at it, this is going to dwarf the local landscape. You'll see this from miles away. Okay, so in Brescia, 75% reduction, and you've said 25% of the original trash goes to an ash landfill. In San Francisco, 77% reduction, only 23% residuals. And now look at the residuals are far less toxic than the toxic ash, far less toxic. And you can screen the toxics out using the facilities built in front of the landfill. 7, incineration puts highly toxic and persistent substances into the air. These include acid gases like hydrogen fluoride, hydrogen chloride, toxic metals like lead, mercury, cadmium, etc. By the way, I'm a little puzzled. Looking at the tables, I didn't see any reference to mercury, which is rather strange and important because mercury is very difficult to capture in incineration. What they found, they could capture mercury using activated charcoal, which is one of the reasons we now have it injected, activated charcoal, activated carbon. That captures the mercury and some, if not most of the dioxin. But they were only capturing mercury if the temperature, I think, was below 140. I remember the research papers came out above 140, the charcoal didn't capture the mercury. And the emission gases for this facility are predicted to be about 175, 180 degrees Celsius. So they're not talking about mercury, and for what I can see, they may not be capturing any mercury. And for fishermen around, if you've got lakes anywhere near, it only takes 1/3 of a gram of mercury in a 25-acre lake, a 10-hectare lake, to contaminate the fish with organic mercury to the point that a pregnant woman shouldn't eat those fish. So you might want to look to see if you've got any small ponds or lakes where people fish. That's going to be a problem both for the dioxin contamination in the fish, the fish concentrate the dioxin and the mercury. And finally, dioxins, furans, and a whole new bunch of substances called the forever chemicals, PFOs, or perfluorinated organic substances. Here we are again on the picture. The perfluorinated substances are highly persistent, forever chemicals, because they contain lots of carbon-fluorine bonds. Though in their raw, they're highly persistent in the environment, highly persistent in our bodies. And when you burn them, you produce a whole host of tiny fluorinated byproducts, which can be devastating for human health. Now, there was one incinerator that got away from us. We stopped 300 incinerators from being built in the States. This is one that got away. It was my fourth incinerator that I fought in 1985, 86. We lost, but look, here we are in 2018. It's still running. And out of 351 air emission sources in New York, it was number 1 for dioxin emissions, number 1 for beryllium emissions, number 2 for cadmium, lead, mercury, and number 3 for arsenic. Look at that mercury, what I was saying about mercury. Number 3 for arsenic, number 3 for chromium. Now I want to get into dioxins, I've done a lot of research on dioxins, published 6 papers with a colleague on dioxins. The major problem with dioxins and related compounds is they are highly persistent and accumulate in the human food chains, both the terrestrial and the aquatic food chains. These are your big problem for dioxin. And what has New Zealand got? millions of these things, grazing cows, grazing sheep, grazing goats, and chickens. And they're all capable of concentrating dioxins to an enormous degree, as you will see. I did a paper with my colleague Tom Webster in published in 87, it's presented in 86. We showed that 1 liter of cow's milk would give you the same dose of dioxin as you would get if you breathe the same air as the cow is breathing or getting when it's grazing its area. So you don't have to actually breathe the emissions to get the dioxin. You have to consume food that's produced in the area of incinerators. And this is one of the reasons you don't want incineration anywhere in New Zealand, because you're a largely agricultural economy and you have to sell your agricultural products throughout the world. Now, this study we did in 87 was essentially vindicated in 1995 when a group in Germany showed that a grazing cow would consume the equivalent amount of air. What they did is they worked out the grazing area that a cow had, the typical area. Then they produced a cylinder of the amount of particles and gases which fell on that grazing area in 1 day. And that amount of air that cow was breathing, a human being would take 14 years to breathe in that same amount of air. So you'd have to breathe the air next to the cow for 14 years to get the same amount of dioxin that cow is putting into its body and spreading around eventually the New Zealand population. Now, the same just as with animals, human body, human animals, the dioxins accumulate in our body fat. And in our lives, for a male, that level of dioxin in our body fat increases every year. We can't get rid of it. But a woman has a way of getting rid of the dioxin in her fat. It's called having a baby. And so, in other words, when she gets pregnant, for 9 months, the dioxin in the mother's body fat is moving across the placenta into the fetus. And so that fetus is getting a large chunk of what that woman has accumulated from her food for 20 years. And the worry here is that you don't see the effects until the baby's grown up. I'll talk about that in a moment. But basically, it's 20 years before you get the major impact on human beings, is on the next generation of children born in that area. And lo and behold, the baby's born to a woman who's grown up on a farm and is eating the food from that farm, because she's going to get the highest dose in the community from an adult point of view, and then she gives that dose to her first child. So the problem here is that dioxins act like hormones. Hormones regulate development, and the 6 hormones that dioxin is known to interfere with interferes with sexual development, thyroid development. In other words, dioxins interfere with mental and sexual development. And this paper by Linda Birnbaum was an absolute classic. And if anybody's interested, they should get hold of it. And these people made it much easier to understand this issue of how man-made chemicals behave like hormones, where dioxins were the classic example. They wrote a whole book about this, and it reads like a detective story, how they put these pieces together, how dangerous these endocrine disruptors, these chemicals that mimic human hormones, are to the future. To make matters even worse, incinerators are poorly monitored. Take dioxins. Dioxins traditionally have been relied on a once-a-year 6-hour test. Once a year. Once a year, they put a probe into the flue gas halfway up the chimney, collect a sample for 6 hours. Those filters are sent away to a lab, and a few months later, somebody, usually not the public, knows what was happening on that day. But on the day they're measured, the company knows they're coming. They have a chance to clean up their waste, keep out the really nasties. And if the machine misbehaves when the test is going on, the test is shut down. So you're getting 6 hours of ideal data, and these 6-hour tests are missing startup, shutdown, and upset conditions. And some countries are now using but before I mention that, I just got a communication from England that says that a modern incinerator built in Paris, which I saw shortly after it was built, had 3,000 hours of upset conditions. Now, typically you've got 8,000 hours in a year, 3,000 hours upset conditions, startup, shutdown, and blah, 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 blah. Now, they found that one upset condition, one startup, can give you the total emissions projected for the whole year, based upon a 6-hour test. So now companies are using 4-week samples. This is the AMESA system. And even these are underestimating emissions. And here's some documentation of AMESA. You can look up AMESA on the web page and you'll see their description of what they do and why they are important. Here's where they say, over the last 10 years, it was discovered that especially during startup and shutdown periods, state-of-the-art incinerators, the dioxin emissions in the flue gas can increase compared to normal operations by a factor of 1,000. By a factor of 1,000. So it depends on how long your upset condition is, but how long can you have emissions 1,000 times higher than you say you're getting based upon the 6-hour test before you start going way over what you're supposed to be doing? Now, this is a very, very important study from Europe, from a very important NGO called Toxico Watch, and Zero Waste Europe has done a good job of communicating this research around the world. And the first incinerator that this company, Toxico Watch, monitored was this state-of-the-art incinerator in the Netherlands, which when it was built, one of the ministers said was one of the best in Europe. And it was built in the tippity-top corner of the Netherlands. Oh, and they had all the air pollution known to modern man on this incinerator. And they were pretty confident they were going to meet the best standard that they could come up with. But then this company, Toxico Watch, came in, and for the first time in the history of the Netherlands incinerators, they did long-term continuous sampling of the flue gas instead of the 6-hour samples. And they not only looked at dioxins and furans, but they looked at related compounds, including the PF polyfluorinated compounds. So there's a whole array of things that they can monitor on a 4-week sample. Well, look at this. This is the table. And I want you to note the short-term tests of the green arrows. You see the green arrows on the left? Those are the 6-hour tests. 6-hour tests. And the computed concentration, oh, that looks wonderful. Look at those. They're wonderful, very, very low. But then look at the red arrows. These are the 4-week sampling. And the red I've circled, that's how much more dioxin was emitted as computed from the 4-week samples compared to that computed from the green, from this 6-hour test. So many countries, including the United States, has functioned using 6-hour tests, and the public has been absolutely conned. This is a confidence trick to use these infrequent 6-hour tests instead of these 4-week tests. But imagine the surprise of the Dutch when they found that even these 4-week samples was not getting all the dioxin. To do better than the long-term samples, you have to monitor the environment, and particularly monitor chickens. Now, chickens are marvelous. They are the best biomarker of a local source of dioxin than you can imagine. They not only eat the soil, but they eat everything in the soil, the grubs, the worms, the insects, the microorganisms, and they absolutely biomagnify all the dioxin in all those little critters into their flesh and eventually, of course, into their eggs. And this company, ToxicoWatch, has a technique for monitoring the eggs of chickens in backyards. You see these numbers. Now, to put those numbers in perspective, the Dutch standard of safety, you're not supposed to eat eggs in Netherlands greater than 1.7, certainly not above 3.4. So where were these eggs collected from? Answer, near the incinerator. There's the blue arrow pointing to where the trash incinerator was, and you see the ones with those very high parts per trillion orange eggs are the ones close to the incinerator. You have to go several kilometers before you get the green ones below the standard. So I tell you right now, if for some unbelievable crazy reason they build any incinerator in New Zealand, the public must insist upon the chickens' eggs being monitored in the area. And you should find out right now if anybody is actually producing eggs in their backyards. You should start saving them now, putting them in a refrigerator, have a lawyer date them so that you've got background levels. Should the facility cut, well, you could wait until they've given the okay. So you need the background. You need the background to compare with whatever happens when the incinerator goes online. Now, I've said this before, I'm going to say it again. You need 3 things to protect the public from incinerators. You need strong regulations, and in New Zealand, you probably don't have strong regulations right now for the incinerator emissions or for the ash disposal. You need adequate monitoring, and you would need the monitoring of chickens' eggs and 4-week sampling at least, possibly the monitoring of lichens and moss for mercury and other toxic metals, monitoring of fish in the area. And thirdly, you need tough enforcement. And if any of those links are weak, and I think they're all weak in New Zealand, the public is not going to be protected by this project. And saying that they've done this safely in Germany is a hill of beans. And let me tell you something else which shocked me. As far as I can tell, they have not monitored chickens' eggs near incinerators in Germany. So that's the first thing you can ask for is, please give us the dioxin levels in chickens' eggs near incinerators throughout Germany, and in particular near the one that's being proposed for Waipa district. And again, making this even worse, is incinerators produce highly toxic nanoparticles. Now, the most toxic emissions, toxic metals and dioxins, are enriched on the surface of tiny particles. Why? Because the tinier the particle, the greater of surface area for a given mass of material. So these nanoparticles enrich the nasties. We're talking about the toxic metals, the dioxins, the furans, and probably the PFOs are enriched on the nanoparticles. And if you want to learn about nanoparticles, there's an excellent article from Stephanie Cormier from 2006. Barry Dillinger, the co-author there, is one of the United States' best combustion engineers. And they explain how these nanoparticles are formed. Now, here's the shocker. There are no regulations and no monitoring for no particles emitted from incinerators. Remember what I said, you need three things. You need strong regulations, adequate monitoring, and aggressive enforcement. Well, you're not monitoring, you've got no regulations for nanoparticles, you're not monitoring the nanoparticles. The public is not being protected from nanoparticles. Now, the regulations for incinerators in Europe and the United States are either 10 microns or 2.5 microns. But both standards miss these nanoparticles, which are less than 1 micron. Now, we know that both sickness and death can be related to the particulate levels in cities. So if you look at a long list of cities and you look at their particulate levels, the morbidity rate and the mortality rate in those cities increase with the particle loading. And the smaller the particle that are measured, that relationship gets stronger. And so you can predict, I think anybody can predict, that the relationship with nanoparticles is going to be even worse. Why? As far as health concerned, once you breathe in these nanoparticles, they're so tiny, they can squeeze through the membranes. There's no defense for them. The membranes are made of lipid and protein, which are big molecules. The nanoparticles just squeeze between them into the bloodstream. And once you're in the bloodstream, they are circulated throughout the body and can enter every tissue in the body. Every tissue has a membrane, it can go through it. Every cell has a membrane. And this is a particle in brain tissue. And that particle contains lead, barium, chromium, iron, and silicon. And you really don't want those particles in your brain. Now, in 2019, there was an article, this is a report in The Guardian, but an article showed that these nanoparticles could cause inflammation of the brain, damage nerve cells, change stress hormone production, and have linked to poor mental health. A quote from The Guardian. Now, and then there were reports coming out of the media that there was a study which related the number of nanoparticles in the urban air in Montreal and an increased risk of brain cancer. And this was the study. It was by Scott, and I don't know how you pronounce it, Wiekenthal. And basically, this was in 2020 in the journal Epidemiology, and have for the first time linked nanoparticles in air pollution to increased risk of brain cancer. They found that a 1 year increase in exposure of 10,000 nanoparticles per cubic centimeter raised the risk of brain cancer by more than 10%. So in other words, okay, now this is important for you and for everybody living near an incinerator. If these researchers were able to measure the nanoparticles in urban air in Montreal, then they should be able to measure the nanoparticles in the urban air next in the community hosting an incinerator. And that's what you should insist upon. Both monitoring of the nanoparticles before the thing goes online and then measuring the nanoparticles at subsequent intervals in the community. It can be done, and it should be done for those hosts unfortunate enough to have an incinerator in their community. So Scott Wiekenthal says, anytime you burn anything, these small particles are produced. These particles are so small that can get into our bloodstream and into our brains. And that is confirming what I told you, what I was telling people, 10 years or more. No, what's it, 23? I was telling people about this in the early 2000s. And there have been other papers which indicate a relationship between nanoparticles and Alzheimer's disease in teenagers, and also studies which show that nanoparticles can cross the placenta. So the placenta is not keeping out the dioxins, and it's not keeping out these nanoparticles with the toxic metals and so on. Okay. So summarizing this horrible situation, incinerators, and for that matter, gasification, pyrolysis plants, anytime you use high temperature conversion technologies, you convert thousands of tons of solid waste every day into trillions of very tiny particles, which are difficult to capture and carry the most toxic substances known to man into every tissue in the human body. As I said, from a chemical point of view, from a toxicological point of view, this is a very, very complicated thing to do, to control. And it's not to be put in the hands of novices, novice corporations, and novice governments when it comes to regulating, monitoring these things. And finally, there are better alternatives to incineration. It's quite unnecessary. It's unnecessary in the 21st century. It's unnecessary in 2023. And even communities in New Zealand have shown this already. Even if we made incineration safe, we would never make it sensible. It simply does not make sense to spend so much money destroying resources we should be sharing with the future. And that's a direct quote from me from the 20th century. This is over 23 years ago I was saying that. And every year that passes, the truth becomes more and more visible, even to governments. Incineration does not make sense in the 21st century. Our task is not to find better ways to destroy materials, but to stop making products and packaging that have to be destroyed. Waste is a design problem. I've said this already, but it's worth repeating. The waste problem will not be solved with magic machines, but with better organization, better education, and better industrial design. And finally, the major mainstream and governments around the world, including Europe, had recognized this. Burning garbage, not enough. This is a report from Bloomberg Environment, February the 11th, 2020. And reading this quote, I'm going to have to move this up here. Reading this quote, Democrats in the House understand that the Europeans are onto something. Reducing waste and investing in low-carbon development is both an ecological imperative and a roadmap for economic growth. But these lawmakers may be overlooking one important plank in the European Sustainable Growth Plan. Don't burn garbage to make electricity. And what are your promoters saying? Oh, look at Europe. They have all these incinerators. Nothing to worry about. Yes, you have something to worry about. The EU classification system tells investors what types of projects and activities should be considered green. To put it mildly, burning municipal solid waste to make electricity did not make the list. Bloomberg, all the investors all over the United States are reading this. You don't think they're going to be investing. I'm sure investors in Europe are also reading this, but let's go to Europe. Okay. This is from Yale Environment. There's the link. This is from 21. Okay, yeah, April the 1st, 2020, not an April Fool's joke. In Europe, a backlash is growing over incinerating garbage. For years, European countries have built, quote, waste-to-energy incinerators, saying new technology minimized pollution and boosted energy production. But with increasing concern about the plant's CO2 emissions, the EU is now withdrawing support for these trash-burning facilities. For decades, Europe has poured millions of tons of its trash into incinerators each year, often under the green-sounding label waste-to-energy. Now concerns about incineration's outsized carbon footprint and fears it may undermine recycling are prompting European Union officials to ease their long-standing embrace of a technology that once seemed like an appealing way to make waste disappear. The European Union is in the process of cutting off funding for new incinerators. And you can find out more why this doesn't make sense if you want to fight climate change. But I've said that already, so let's go on. I will read this. It all comes as the European Union is pushing to reduce waste, particularly plastic, by ratcheting up targets for composting and recycling, mandating that plastic bottles contain 30% recycled content by 2030, and banning, as of this July, single-use items such as cutlery, cups, and stirrers. The EU Union has also adopted a new circular economy plan that aims in the longer term to encourage better product design so reuse and recycling are easier. Continued incineration, critics argue, could threaten these goals. Once built, they say, incinerators cannibalize recycling because municipal governments are often locked in by contracts that make it cheaper to get their rubbish burned than to sort it for recycles. Cannibalize recycling. There's a better way of recycling waste tires. You cool them with liquid nitrogen, a cryogenic process. And then when you put those through crushers, they go to a powder. You can separate the nylon from the rubber and the stainless steel belts, being done in Canada. Much safer and in the long run, much better for the environment. Talking about England, in Cambridgeshire, the leafy, well-off home of the University of Cambridge, my alma mater, plans for another plant stalled in the face of vocal opposition from residents. And this is a plan to build an incinerator. But such decisions can raise uncomfortable questions for other authorities, including Edmonton, which the incinerator is a neighborhood of large Black and immigrant population. Is one of the country's lowest income areas. And these activists are saying, why is incineration not good enough for Cambridgeshire, but it's good enough for Edmonton, which is poor, racially diverse, and already suffers with a lot of pollution? This is the nub and crux of what we call environmental racism. The most polluting entities end up in the poorest communities, or communities that perceive themselves as deprived, or communities that are seen as marginalized or out in the boonies. These communities are preyed on by incinerator companies. They use this is economic development, this is jobs. These are the typical arguments to seduce local communities to think they're getting something good rather than something that no other community in their region or their country wants. So I've been promoting zero waste since 1999, especially in Italy. And I first heard about zero waste at a conference in San Francisco in 1998. And I shot a video at that conference, and you can still watch this. It's called Zero Waste, an Idealistic Dream or Realistic Goal. I concluded after interviewing all these experts for 60 minutes that it was a pretty realistic goal. I've promoted it ever since, particularly in Italy, which I've now visited 89 times. I came back from my 89th visit yesterday and spoken in over 300 communities in Italy. And Italy has spearheaded both the anti-incineration movement in Italy and the zero waste movement, the best in Europe. Led by this primary school teacher, who's now retired, Rossano Ercolini. Don't Burn Our Future was the title of his book. And the three of us, Rossano Ercolini and Patricia Losciotto from Trapani in Sicily, we wrote this book, Rifiuti Zero, A Revolution in Progress. And much of that material, this was in 2012, and much of that material I pinched and reprinted in English in this book, and to give it its full title, The Zero Waste Solution, Untrashing the Planet One Community at a Time. Some people don't understand untrashing. Should be the zero waste solution, saving the planet one community at a time. Go to Raglan to see their zero waste strategy in action.
Yep.
The zero waste movement is a success story in Italy. Here are the 2017 figures. Out of 40 provinces out of 108 are above 65% diversion from landfills. The four best are over 80%. Treviso, population 1 million, 88%. 3,000 communities over 70%. 1,000 over 80%. Over 100 over 90%. And the 2020 figures, over 4,000 communities above 70%. 1,580 over 80%. 165 over 90%. And the European Commissioner had this to say. In his reference, he made reference to the zero waste schemes in Campania, Treviso, and Parma as living examples of operational implementation of the principles tabled in the circular economy package. So the European Union moving from the linear economy to the circular economy, and they point to Italy as an operation, a living example of the principles needed to move towards a circular economy. And I will give this presentation in a few months' time, whenever you need it. But particularly when the incinerator is done and dusted, come back to me and I'll talk about the 10 steps to zero waste. Here they are: source separation, door-to-door collection, composting, recycling, reuse, repair, zero waste research center, economic incentives, pay-as-you-throw systems, the ban of single-use plastics. And after all of that, you get to 80% with that. And then beyond that, you need a separation facility in front of the landfill where you can sort out more toxics and stabilize the dirty organic fraction. And yes, you need a landfill for this small quantity of residuals, but that landfill should get smaller and smaller and safer as we get better and better at steps 1 through 8. That 9 ban single plastic should be number 8. So zero waste is a combination of community responsibility, the 3 R's: reduce, reuse, recycle, and don't forget composting, and industrial responsibility. A community cannot get to zero waste alone. It needs industry to change the design of single-use plastics, throwaway plastics, throwaway objects. That should be obsolete. We need good industrial design to do that. And the attractive thing about the zero waste solution, it involves everybody. Everybody has 10 things. Everybody can start the process with source separation if you've got local political leadership. And whilst it starts with these 10 things, it ends up here with some of the brightest minds in our society. Industrial designers, professors and students at university. We put them in zero waste research centers. They've done that in Italy. There's a lot of positives here. In fact, the zero waste strategy is a very, very positive movement because it builds better communities. So zero waste is better for the economy, more jobs. It's better for our health, less toxics. It's better for our universities, more meaning. It's better for the planet, more sustainable. And it's better for our children because it gives them more hope for the future. And it's like a staircase. To get to your bedroom, you jump 8, 10, 12 feet. You go up one step at a time. And the same with the 10 steps to zero waste. You can bring on these things as you get better and better at the early steps. So you not only give children hope, there are solutions, they're happening around the world, but you're giving them a strategy in which they can play a part. They may even get their livelihoods later on in some aspect of zero waste. And I leave you with this thought: as activists, you're probably pretty miserable about being exposed to this potential source of pollution, not potential, source of pollution, which you don't want. And you think your lives being turned upside down, but there is a good side to this, and that is a threatens community, is a strengthens community if people pull together. It's what happens in wartime. You have a blitz on London. It made the British more and more determined to beat Hitler. And the same with this. You threaten the community with this dreadful facility, and the people will come together, old and young together, rich and poor together, black and white together, coming together as a community. And after that process for a few months, you will have made a lot of friends for a lifetime, and your community will be better and prepared, I hope, once the battle is over, to start the real battle, which is to be one of those communities in New Zealand which is working towards zero waste. So finally, 3 final messages. The first message to citizens: don't let the experts take your common sense away. They make these reports look so, they know everything. I know nothing. What am I? I'm not an engineer. I'm not a chemist. I'm not this, that, and the other. But use your common sense, especially when we get to zero waste. Zero waste is common sense in action, period. And to politicians, put your faith back in people. Waste is a local problem. Don't think that it's going to be solved by German engineers, consulting companies, magic machines. No, it's your people that will solve this. There are clever enough people to organize and do everything that's needed to support the facilities that your government can support locally, regionally, nationally. And finally, to activists, have fun. You've got to enjoy this. If you don't enjoy it, you won't be much help to anybody. Steel yourself for a few months. You can be masochistic for a few months, but after that, to keep going, you need to have fun. And one of the ways I have fun, I love doing this. I love meeting people. I've loved meeting people all over the world in 69 countries. I love meeting them in person, and now I like meeting them by Zoom. But I have this song which you can sing on marches. Hopefully you'll march at some point to the company's headquarters or your local MP or wherever you need to change. And this is a lovely marching song for the United States. Whilst we recognize our landfills all are swelling with the waste, that doesn't justify a bad decision made in haste. Let us put our heads together so the problem may be faced, and we must do it now. Ba-ba-ba-bum. We don't want incineration. We don't want incineration. We don't want incineration. We know there's a better way. Mine eyes have seen the garbage that's a smouldering on the grate. We must stop incineration before it is too late. Unless we wish the dangers, we had better separate, and we must do it now. We don't want incineration. We don't want incineration. We don't want incineration. We know there's a better way. Zero waste! Zero waste! If you're not for zero, how much waste are you for? God recycles, the devil burns. Thank you for those who've listened for this presentation for about 90 minutes. You have my permission to share it with anybody, with your MP, with your neighbors, with your friends in this country, in other countries. And yes, I'm prepared to do it again and again in other communities in New Zealand, in Australia, in Japan, in Malaysia, throughout the world. So be my guest. Share this, share the PowerPoint. You can get the PowerPoint from Nick, who's kindly organized this recording. I can send it to you. My email address, you may want to make a note of this, is pconnett, that's PCONNETT @gmail.com.